Hello Primary 6, we are going to answer the revision sheet together. Let's get started. The first type of question, complete. Question number 1. Levers were first described by a scientist whose name is, what is the name of this scientist? Is Archimedes. Is Archimedes. In English we call it Archimedes. Number 2, the fixed point where the rigid bar rotates on is called the fixed point. So this is what? Yes, it's fulcrum. Number 3, the crowbar is considered a which class lever? First, second, third. Crowbar is first class lever. So the crowbar is considered a first class lever where the fulcrum is in the middle between the resistance and effort force. Number 4, the values of effort force and resistance force depend on effort R and resistance R. So the values of effort force and resistance force depend on effort R and resistance R from the law of levers. Number 5, the force and the resistance are equal in levers if the force and the resistance force are equal in levers if the effort arm equal to the resistance arm. Okay, according to the law of levers. Okay, so the force and resistance are equal in levers if the effort arm and resistors arm, they are equal. Number 6, if the effort force is larger than the resistance force, that means what? Do you remember when we said that there is inverse relation between force and arm? That means when the effort force is larger than the resistance force, so the resistance arm is longer than the effort arm. Okay. So if the effort force is larger than the resistance force, that means resistance arm is longer than the effort arm. They are opposite. Okay. When we talk about force, we say larger than. But when we talk about arm, we say longer than. Okay. Number 7, the lever saves effort if the which arm is shorter than which arm. Do you remember when we said that to save effort, the effort force must be smaller than the resistance force? Okay, so that means the resistance arm longer than the effort arm. Okay, again, to save effort, that means effort force smaller than resistance force. So that means resistance arm longer than effort arm. Okay, so which arm is shorter than which arm? So again, the lever saves effort if the resistance arm is shorter than effort arm. That means resistance force larger than effort force. Resistance force larger than effort force. So this is save effort. Okay, again, the lever saves effort if the resistance arm shorter than effort arm. Resistance arm shorter than effort arm. Number 8, electric lamps convert or changes which energy into which energy? Electric lamps, so from electric energy into light energy, from electric into light. Number 9, the filament of the light bulb is made of what? Very easy. Filament of light bulb is made of, yes, tungsten. Number 10. The fluorescent lamp contains the inert what gas and a little amount of what? The fluorescent lamp contains the inert, yes, argon gas, and a little amount of mercury vapor. Number 11. The inner surface of the tube of the fluorescent lamp is covered with, who remembers? Yes, phosphoric material. Number 12. When the electric lamps are connected in parallel with others, the light intensity in parallel, so the light intensity doesn't change, okay, doesn't change, but in series connection it changes. Second type of questions, write the scientific term. Number 1. The fixed point of a rigid bar, this is very easy, yes, fulcrum. Okay, number 2. The type of levers where the effort force is always smaller than the resistance force. Okay, effort force smaller than resistance force, that means resistance R longer than effort R. The distance effort R bigger than longer than resistance R. Effort R longer than resistance R. So resistance, that means resistance in the middle between fulcrum and effort force. So this switch type, the resistance between fulcrum and effort force. So this is second class lever. This is second class lever. Number 3. Levers that sometimes conserve effort, sometimes, so this is first class levers. Always conserve, second class lever. Doesn't conserve, so this is third class lever. Okay, so sometimes conserve effort, so this is first class lever. 4. Types of levers that always doesn't save effort. Doesn't save effort. We said before, doesn't save effort, so this is third class lever. A tool that changes electric energy into light energy, from electric into light, so this is electric lamp. The scientist who invented the light bulb, we said before, it's called Archimedes. Sorry, not Archimedes, Archimedes for lever, but light bulb, Thomas Alva Edison. 7. The method of connecting electric lamps and machines at home. At home we use parallel connection. Number 8. The way by which the bulbs are connected by branching roots, and the lightning of the lamps is not affected with increase in their number. So branching roots and not affected with increase in their number. So this is parallel connection also. Okay, the third type of questions, give reasons for. Number 1. Water pump is a first class lever. Why? Any lever in first class lever, we will say because it has fulcrum between effort force and resistance force. Again, because it has fulcrum between effort force and resistance force. Because it has fulcrum between the effort force and the resistance force. Number 2. Seesaw is the first class lever and wheelbarrow is second class lever. The same answer, because seesaw has fulcrum between effort force and resistance force, while wheelbarrow has resistance force between fulcrum and effort force. Okay, so because seesaw has fulcrum between effort force and resistance force, while wheelbarrow had the resistance force between effort force and fulcrum. Number 3, in second class levers, the effort force is always less than resistance force. In second class levers, the effort force is always less than resistance force. You know, in second class lever, the resistance between fulcrum and effort force. So that means resistance force is shorter than the effort force. Resistance force shorter than the effort force. Sorry, the resistance arm is shorter than the effort arm, or the effort arm is longer than the resistance arm. So because in the second class levers the effort arm is always longer than the resistance arm. Okay. The next type of question, problem. Let's read the problem together and answer it. A lever is affected by force 100 Newton. Affected by, so this is effort force 100 Newton. The length of force arm is 5 centimeters. Force arm is 5 centimeters and resistance arm is 20 centimeters. Calculate the resistance force and mention if this lever saves effort or not. Okay, firstly we must write the law of levers. So the law of levers, effort force time its arm equal resistance force time its arm. Okay, let's put numbers. Effort force equals 100 Newton affected by force, so this is effort force 100 Newton. Okay, time its arm is force arm is 5 centimeters equal resistance force, we need it, time its arm, which is 20 centimeters. Okay, so we have effort force, force arm, resistance arm. Okay, calculate the resistance force. It's very easy. So resistance force equal 100 times 5 over 20. So this it will be 25 what? 25 Newton. Okay, it's force, resistance force, so its unit is Newton. Okay, mention if this lever saves effort or not. Okay, look at its arms. The resistance arm 20 and the effort arm 5. So the resistance arm longer than effort arm. The resistance arm longer than effort arm. That means effort arm in the middle between fulcrum and resistance. This is third class, and you know third class doesn't save effort. So the answer is this lever doesn't save effort. This lever doesn't save effort. If the resistance arm longer than effort arm and the effort force larger than resistance force, effort force 100 Newton and resistance force 25. So this is doesn't save effort. doesn't save effort. The effort force must be small to be save effort. Okay, thank you.